For this next section of our reasoning and proofs chapter, we're going to take these conditional statements and we're going to observe different ways we can rearrange them with our if-then hypothesis and conclusion. What I want you to do first is pause the video and go find two colors. Like what we did, at least with my students, we did a hypothesis in one color, conclusion in the other. We're going to need those two different colors again, okay? The first things first on our warm-up, I'm going to have you guys just avoid this. There's nothing here to do, so we'll just jump straight into going back over what we call conditional statements. Our conditional statements are what we start off with our hypothesis and our conclusion. We are looking at this if-then form. You have to have if and then. Between the hypothesis and conclusion, you have a comma. So we talked about in our previous video about the conditional statements. The hypothesis is after the word if, all the way to before the comma. Your hypothesis, we now need to make sure we talked a little bit about P and Q, but you need to know these letters. P comes before Q, hypothesis before conclusion. Your hypothesis is represented by this lowercase p. This is one of your two colors. Your conclusion are the letters that are after the word then, do not include the word then, and goes to the end right there. The angles are complementary. This is your conclusion. Your conclusion is represented by the lowercase q. This is going to be very important to see because you're going to see letters switching around. Your conditional statement is going to say that if P, then Q. That is what this right here means. If P, then Q. So your hypothesis and your conclusion. This is why we don't include if and then in our when we pull out the hypothesis and the conclusion. When we take this conditional statement, one way we can arrange it is called the converse. The converse, all we do is we take the hypothesis, we take the conclusion, and we're going to switch them around. So in the symbol notation here, I'm going to use the same colors. I have pink for hypothesis, blue for conclusion. Pink for hypothesis, the letter P. We're going to notice it comes last here. And my conclusion, the Q, comes first. So we're simply going to take these two statements and rearrange them. If stays where it is, the comma and then stays where it is. We just take these words and these, we literally just pick them up and switch them around. So to jump right in, we are going to go ahead and write the converse of each of the following conditional statements, and we're going to determine, is the converse true or false? Okay, this is going to become an important thing later. Is the converse true or false? Now, reviewing from 2.1, if the converse is false, we have to provide a counterexample to show it's wrong. Let's take it one at a time here. A, if the measure of angle A equals 90 degrees, then angle A is a right angle. Get your colors. Original hypothesis, whatever you did your first color with right here, P, we're going to highlight measure of angle A is 90 degrees. Do not highlight the if. Do not. Your conclusion, whatever color you did with the Q over here, should be angle A is a right angle. Never highlight the if or then. What we want to do, we leave the if. We're going to take the hypothesis, measure of angle A is 90 degrees, and the conclusion, angle A is a right angle, and we're simply going to switch them around. I'm going to go ahead and have that show up on the screen so we can see what it looks like. This is the sentence. Now watch what's happened here. In our original conditional statement, we had our P and our Q, hypothesis and conclusion. I have now taken angle A is a right angle, the conclusion, and it's right here. There's your Q. And again, not including if and then in any of these highlightings. Measure of angle A equals 90 degrees is now over here. All we did with converse is switch them up. If you're one of my students, the way you can see you're going to switch them is I wear a lot of Converse, and I have a lot of different pairs. So I switch my Converse. I don't wear the same pair all the time. Sometimes I switch them. It's the best way I can help with my students. Now, we have this switch. We have the P and the Q. switch them around. We want to see, is this true or false? If angle A is a right angle, does it measure 90 degrees always? Well, yeah, that's the definition. We'll get to that later on with this unit. So we don't have a counterexample. No counterexample if the statement is true. So we're going to skip that part. Let's look at B. If school is in session, then it is a weekday. All right? After if, just the words school is in session. There's your hypothesis, P. It is a weekday. That's going to be your conclusion, Q. Again, you do not see me highlighting if or then because you're not supposed to. Here's Q. Your converse, we're going to take what I have as my hypothesis and conclusion, switch them around. So go ahead, pause it, and try it on your own. Just switch those words around. Okay, see in here, I took it is a weekday, the conclusion. Now, it is a weekday is first. There's my Q. School is in session, a hypothesis P, now comes second. School is in session. Switch them around. Now we want to look at, is this true or false? Well, if it is a weekday, does that mean every single weekday school is in session? Or is there a weekday you can think of that we don't have school? I can think of a lot of different days, so I'm going to put false. And what I'm going to put as my counterexample is, well, with our students, we just had Labor Day off. You've got Thanksgiving, summer vacation, spring break. These all involve weekdays that we do not have school in session. So this is going to be your converse. Take P and Q and switch them right here. Okay, we've switched those two letters around. Now we say if Q, then P. The last one in this video we're going to talk about, we're going to split this up a little bit. The last one we're going to talk about is called the inverse. Okay? We look at the inverse, like fractions and stuff, we're looking at the opposite. Okay? Here with the inverse, what we want to do is we want to do what's called negate both the hypothesis and conclusion. Look at your P and Q, guys. We're keeping P and Q exactly as is. We're going back to our original conditional statement, if P, then Q. The little squiggle line just means not. Okay, so all we're going to do is we're going to negate. Keep in mind, if it already says not and we negate it, it's going to be a double negative, making it a positive. So what we're doing is we're taking each one, doing the opposite. So we take our conditional statement right here. Actually, let's go ahead and write opposite underneath negate. So it says it is, we change it to isn't. If it says it isn't, we change it to is. So we're going to go ahead and write the inverse of these conditional statements. We're not going to worry about counterexamples and if they're true or false. Okay, we don't need that on here. Let's take a look at the first one. If the measure of angle A equals 90 degrees, then angle A is a right angle. We're using the same two examples as before. Hypothesis, grab your hypothesis color, same one. We are going to highlight measure of angle A is 90 degrees. That is it, no if. There's your P. Your conclusion, angle A is a right angle. Again, you see I am not highlighting ifs or thens. You never do, never. The inverse, we're going to keep P and Q where they're at, but we're going to change it to the opposite. So the first one says if the measure of angle A equals 90. So we want to say if the measure of angle A is not equal to 90. So this is how we'll write it. If the measure of angle A not equal is an equal sign with a line through it, not equal to 90 degrees, comma, then we need to change this one too. Angle A is a right angle. We need to change to angle A is not a right angle. And we'll look at the highlighting here. We still have P first, but now we have changed P, a measure of angle A is 90. We have now negated it. We've changed it. There's that squiggle line. We've said not equal to 90. Our conclusion, guys, I am so sorry. We need the word then in here. I cannot believe that I forgot that. I'm not restarting the whole video because of that. We do need then angle A is not a right angle. So you can see I make the mistake. A lot of us can. Okay? Then angle A is not a right angle. Angle A is a right angle was our conclusion, but now we added the negation to it. So we still have Q, but because we changed it from is a right angle to is not a right angle, we have negated it or taken the opposite. B says if a school is in session, then it is a weekday. Let's look at our hypothesis and conclusion. Hypothesis, school is in session. Conclusion, it is a weekday. We need to change our P and change our Q to the opposite. So let's take P, hypothesis. If school is in session, what's the opposite of school being in session? If school is not in session. Comma. So we still have the school in session as our hypothesis first, but we changed it to the opposite. If school is not in session. Our conclusion was then it is a weekday. We need to change this to the opposite. What's the opposite of being a weekday? Not a weekday. That's going to be the easiest way to do this. I was going to say, and I did remember my then. It is not a weekday. You could put then it is a weekend. You're allowed to do that. What's the opposite of a weekday? A weekend. So here again we have it is a weekday, but we added in that not. Conclusion and hypothesis are still in the same places. We're going to take this next one and we're going to decide which one is the inverse of the conditional statement. If x plus 7 equals 12, then x equals 5. So we need to remember with the equal sign, how we can change it to not equal is simply put the slash in it. Inverse, we are just changing each one. Hypothesis, x plus 7 equals 12. We need to look here and find out where does it now say x plus 7 does not equal 12. Right here at B, checking to see that our conclusion, x equals 5, has changed to x does not equal 5. This concludes the inverse and converse. We will look at contrapositive and biconditional in a separate lesson.